Hi guys, this is the last topic of circular motion, that is vertical circular motion. Very important topic. Most of the NEET questions are asked in this area. When you have a clear idea about this, you can solve many NEET questions regarding the work energy power. Okay, let's see what is a vertical circular motion. It's so simple topic. You only want to learn what is the minimum speed at different cases when it is rotating or in the circular motion. Let's see. The object can assume whether it's a ball or any object. It seems to be in this motion and completing the circle and moves. This is a vertical circular motion. Now when it's moving, at this point there may be two chances may happen. Suppose it's to be complete, it's to be moving the same motion and complete its circle, or otherwise it may be fall down. It all depends upon its velocity of its movement, whether it can complete the circle or else it can fall down. When will be its fall down? Generally, reaching this point, top point, it loses its point of contact. When it is losing the point of contact, it generally loses the normal force or as well as tension. It may differ from case to case. When you're looking at that, a simple object is rotating, it loses a normal force, whether it's an electrostatic force, whatever, it generally loses its centrifugal force. At this point, it loses its centrifugal force. Only two forces is going to act upon. One is centrifugal force. You have very good idea about the centrifugal force, which I have discussed in the previous video, and gravitational force. Only these two forces going to act upon and velocity in this direction. So what we need to find is what the speed. What is this speed at this point? What is the speed at this point and this point? Okay. How can we find this? Only a simple equation. I'm just going to equate. At the top point, when it's the top point, suppose it seems to be a circle. At this point, I need to find its velocity. Generally, it loses its point of contact, hence it has only two forces. One is gravitational force and another is centrifugal force, that is mv square by r. I'm going to equate it. These forces going to be equal at this point. So I'm making mg equal to mv square by r. And I simplify, I would get the value for v top, that is root gr. That's it. Generally, if the object to be in the motion, at this point they may ask two situations, whether it complete the circle or it may either fall down. So to complete the circle, there must be a minimum velocity at this point to complete its motion. That minimum velocity is root gr. This is the minimum velocity the object any else must have to complete a circular motion. Now it's very simple to find this point. By applying conservation of energy, you can easily find out this. Okay, let's see how we can find. At the lowest point at this point is the lowest. I can apply, I assume these to be the 1, this is a point 1 and this to be a point 2. What happened? I'm applying a conservation of energy. What? Applying conservation of energy first in point 1. What are the total energy? What's the total energy? Equal to potential energy plus kinetic energy. Generally at this point, it has kinetic energy. You assume these to be the frame of reference. Whatever the frame of reference can be taken. When I'm solving the work energy theorem problems, you'll get a better idea about it while taking where should I take frame of reference. There is no limit. Wherever the position you can take the limit, the frame of reference, and you can solve it. That's not any confirmed value, confirmed position. Only in this position I should take, or this position I should take this position. Wherever you can take and apply the conservation of energy. What's the thing is, you should maintain the same frame of reference to solving the entire problem. You should not change it. Okay. When I am teaching the work energy theorem and those concepts, I will give you a better idea about that. Okay. Now I am taking the frame of reference at this point. So there is no height, hence the potential energy must be zero. Hence it must be has some kinetic energy because it's moving. So it has some velocity and definitely has a kinetic energy. What's the kinetic energy of mv square? This is the velocity I need to find. This is the velocity I'm going to find. This is the velocity I'm going to find. So at this point, what's the total energy? Only the kinetic energy would be there and there won't be any kinetic energy. Hence, there will be no potential energy, only kinetic energy. Then total energy equal to of mv square. That's V minimum. Whatever the V minimum, that's all. That's V. And just make it B. Don't worry about it. Now, at the topmost point, at the point 2, because I'm going to apply conservation energy in these 2 points. Here the total energy equal to potential energy final plus kinetic energy final. These are initial point now. I'm going to mention this potential energy initial and kinetic energy initial. This potential energy final and kinetic energy final. What is the potential energy? mg into h. What's height here? Height is, this seems to be a radius. This seems to be a radius. And this must be 2 times of radius, that is diameter. So this is h. What's the value of h here? 2r. Hence it has some velocity, already seen that. It has some velocity. What's the velocity? We already find that. What's it? Root gr. The kinetic energy formula of mv square. This v is the velocity at this point. We already find that at this point the velocity is root gr. Then square it up. What will get? When we square it up, we will get gr. That's it. This is the total energy at the point 2 or final. This is the point initial. What the conservation of energy says. The energy never deforms. See, it may deforms from one form to another form, but it does not lose its energy. So, the total energy initial is equal to total energy final. This is the conservation of energy says this. This is the most important. Whenever you are solving the problem regarding the work energy theorem, this is the common method. This is the common first thing, the first formula you are going to use. So I'm going to equate these 2 equations. So that I'm going to equate these 2 equations to get answer. So of mv square, this initial, this is the velocity, we are going to find it up, and here mg2r plus of mgr. Mass will be cancelled. I am just moving this half to that side, then v square equal to here 4gr plus gr. Then b square equal to 5gr and v equal to root 5gr. This is the most important thing. B at bottom. Here at the bottom, these two formulas are very important. You don't need to, when you are a neat student, you don't need to remember any derivations. Only the formulas are important. So, what's the important thing you just keep in your mind is simple. Only these two formulas. When you're knowing this, no need of anything. You just want to know what is the velocity at this point and what is the velocity at this point to complete its circle or to complete its vertical circular motion. So only at this point the v minimum velocity I should provide to this object is root gr, and this point is root 5gr. You got it right? Now we can solve a problem. Yeah, this problem is very important. This is a neat problem. Let's see what's the problem. This is what the problem. A frictionless track ABCD ends in a circular loop of radius r. A body slides down the track from point A, which is at height 5 cm. Find the maximum value of r for a body to complete the loop successfully. In the question they will be provided the diagram. I will give you what the diagram is. Now you got the question, right? Can just make a screenshot of question. I just remove it. Now, what the actual diagram? Suppose these to be the object. What the question says that this is a frictionless track, entirely a frictionless track. That's A and B and C and D, E. This is a frictionless track where the object slides down and complete the circular loop completely. Okay, this is a statement given. Okay, what's the keyword? Okay, what's the given value? What you need to know the given value. This height, they given the height of this. What's that height is 5 centimeter. Okay, you got 5 and the radius of the loop is r. This was given, and another important keyword they are given. What's that? Find the maximum value of r. Okay, then the what's need to find? The r should be known. And the maximum value of r for a body to complete the loop successfully. Complete the loop is the keyword. Complete the loop. So it's completing the loop. So whenever the object completes the circular motion, because loop is a circular, so it's going to complete the circular motion. We already know what's the minimum velocity at this point. What's the minimum velocity at this point and this point. For this question, I'm going to take this point. See, already at this point, I'm going to take, we already know that what's the minimum velocity at this point is root 5gr. So what's the question is, I need to find the maximum value of r to be complete the circle. Okay, the object should complete the circle. So what's the maximum value of r? Okay, this was the question. So what I am doing here, I am going to apply the same conservation of energy. What's that? I am going to take 2 points and this point and this point. I'm going to solve. Means this is the point 1, this is the first initial, and this is to be the final one. Okay, this is final and this is initial. Same way, I'm going to apply the conservation of energy logic. By applying conservation of energy, total energy at the total initial energy is same, potential initial potential energy plus to initial kinetic energy. We already know that potential energy, what's the potential energy formula? mgh. So I'm making here mgh, value of h is 5 centimeters, so I'm making 5 mg plus what's the kinetic energy? Initially it do not has any velocity, hence its kinetic energy must be 0 plus g. So total energy initial equal to 5 mg. That's it. This is the first equation. And at the point final, at this final point, what's that? I'm going to conservation energy, total energy at the final point, final total energy, same potential energy plus kinetic energy. Here I'm taking the frame of reference here, hence do not has any height, hence its potential energy must be 0 because h is 0, but it has some kinetic energy. What's the kinetic energy formula of mv square? We already knows that what is the value of velocity. What's that? Of mv square, when square it up you will get 5gr. We get total final energy. So I'm going to equate it according to conservation of energy. Initial total energy equal to final total energy, and this is the equation 2. I'm going to equate first and second, so it must be equal. So I'm equating 5 mg equal to of m 5gr by cancelling up. What I'm doing here, cancelling 5 m. What we finally get? What we finally get? Okay. The value g also must be cancelled. Okay. Then value of r would be 2. Simply we got the answer. How simple, you see? Very simple. Only you must know in the concept of vertical circular motion. What's that? Minimum speed at this point and minimum speed at this point. You can solve this problem. Very simple. Just I am knowing that what is velocity at this point and this point, and applying a conservation of energy logic, I am solving, I find getting answer. So only in the vertical circular motion you must keep in this memory only 2 formulas. What's that? V top is equal to root gr. V bottom is equal to root 5gr. Keep in mind, I think so it's 2011 or 12. It's an all India pre-medical test. Only this formula alone asked as a NEET question. Very surprising. Only this formula alone are asked as a NEET question. And in 2018, the same problem, this is the problem, this problem is asked. Very simply we can solve by using this concept. When you know this vertical circular motion, then you can easily get 4 marks in your NEET exam. Okay, that's it. Vertical circular motion is over. Let's see in next video. Bye guys.